Let's take a look at this question. This is a 3 by 3 matrix and we are supposed to find the inverse of this 3 by 3 matrix using elementary row or column transformation. Now what kind of transformation can we use over here? Let's use elementary row transformations. So for elementary row transformation, the matrix A is equal to IA. I has to be written as pre-multiplier, that's the first thing. What next? We'll try to convert the matrix on the left hand side into an identity matrix. And how do we do that? We'll go step by step. What are the steps that will follow? I'll explain the steps first. This is a 3 by 3 matrix, let's say, given on the LHS, and we'll convert this element into a 1 first, right? We are using row transformations. So for row transformations, the first column will be solved first. So after converting this 1, this will be converted to 0, this will be converted to 0. Next, this will be converted to 1, right? After that, you can convert both of these to 0. After that, you will convert this into 1. After solving the first column, you will move to the second column. After that, you will move to the third columm. This element will be converted to 1. After that, both these elements will be converted to 0. That's the process that you will follow. First, second, third. And in these, the first elements that you need to take care of are these 1. Okay. So that's the process. That's the order in which we'll move ahead. And during this process, if you get all zeros in any row, during this process, for row transformation, if you get all zeros in any row, you will say that inverse will not exist. Let's say if you were applying column transformations, we'll solve for the first row. After that, for the second row. After that, for the third row. And in case of column transformations, if you get all zeros in any column at any stage, you will say that inverse will not exist for that matrix, right? That's the important thing. So begin by solving. This is equal to A let, and we'll use row transformations to solve. Let's try and solve using row transformations. How do we go about solving for row transformations, right? We'll write A equals IA. That's the first thing, right? I has to be written as a pre-multiplier. That's the most important thing. Once you are through with this, then we can say this is 2 minus 3, 3, 2, 2, 3. This is 3 minus 2, 2 is equal to this identity matrix 1, 0, 0, 1, 0 times this matrix A, right? This is the first thing. What's the first step that we follow? We try to convert this into a 1, right? The 1 element, first to first column, and using row transformations. R1 is replaced by R1 times 1 by 2, right? And what you get is this. 2 by 2 is 1, minus 3 by 2, 3 by 2, rest everything remains same, 3 minus 2 and 2. Mind you, the steps have to be followed very carefully, calculations have to be done very carefully, right? This is 1 by 2, this is 0, this is 0, this is 0, 1, 0, this is 0, 0, 1 times matrix A, right? This is what you get. What else? Once you have a 1 over here, we'll convert this and this into zeros, right, using this one. So R2 can be replaced with R2 minus 2R1. And can you apply simultaneously for R3 as well? Yes, R3 can also be transformed using R1. Both are being transformed using R1. We can do that. R3 minus 3R1. So what you get over here is, the first row remains as it is. First of all, the first row remains as it is, 1 minus 3 by 2 and 3 by 2. They remain as it is. 2 minus 2 becomes 0. 2 minus of this, twice of R1. So minus of minus will become plus, twice of this will become 3. 2 plus 3 will become 5. 3 minus twice of 3 by 2. 3 minus 3, which is 0 over here. This will become a 0. Okay, very interesting. What about the third row? R3 is equal to R3 minus 3R1. 3 minus 3, which is 0. Minus 2 plus 9 by 2. Minus 2 plus 9 by 2. 9 by 2 minus 2, which is 9 minus 4, 5 by 2. This is converting into 5 by 2. 2 minus 3, that is 9 by 2. 2 minus 9 by 2. 4 minus 9, which is minus 5 by 2. This is what we get after this, which is equal to, on the RHS. On the RHS also, the first row remains as it is, 1 by 2, 0, 0. The first row remains as it is. The second row, R2 minus 2 times this, 0 minus 2 by 2, 0 minus 1 minus 1. 1 minus 2 is 1, 0 minus 0 is gone, okay. R3 minus 3, 0 minus 3 by 2, 0 minus 0 is gone, and 1 minus 3 times 0 is 1 again. This times A, this is what I get. This is what I get. And can you please observe that we have solved first column. We have solved the first column complete. Alright. Next we'll focus on the second column using row transformations. We'll convert this into a 1 first of all. We'll convert this into a 1 first of all. Let's do that. How do we convert this into a 1? Let's apply row transformations for converting this into a 1. What's the row transformation that we can apply? R2 can be replaced with R2 times 1 by 5. R2 times 1 by 5. That's a simple row transformation, yes. And what will this give us? This will give us, the first row remains as it is, 1 minus 3 by 2, 3 by 2. The second row becomes 0, 1, 0. The third row remains as it is, 0, 5 by 2 minus 5 by 2, okay, which is equal to what? Which is equal to, first row remains as it is, 1 by 2, 0, 0. The second row gets divided by 5, so you get minus 1 by 5, 1 by 5, 0. The third row remains as it is, minus 3 by 2, 0, 1. This is matrix A, right? On the right hand side, you have a product of A. What else? Once you are through with this, so the next step that you want to apply is you want to solve the second column and convert this into a 0, this also into a 0. So let's try to convert both of them into 0. How do we do that? We'll multiply this with 3 by 2, add over here. We'll multiply this by 5 by 2 and subtract from here. So let's apply both of them, both these steps together. We can do that, yes. So R1 is replaced with R1 plus 3 by 2 R2. That's the first thing. And R1 can be replaced with R1 minus 5 by 2 R2. Right? These are the steps that I am applying. And since this is not required, we can get rid of all of those things and get more space over there, right? So let's get rid of all of these over here. These steps. You may have already gone through these steps. Right. Let's use the space over here and let's solve further. R1 is replaced with this and R3. In the second transformation, we'll have to transform R3. Both of them are getting transformed using R2, which is okay, right? So in one particular step, at least one row should remain same. At least one row should remain same. Right? We are using R2 to transform both of them together. R1 plus 3 by 2 R2. So 1 plus 3 by 2, this becomes 1. Minus 3 by 2 plus 3 by 2, which becomes 0. 3 by 2 plus 0, which is 0. Sorry, 3 by 2 plus 0, which is 3 by 2. Okay, what next? The second row R2 remains as it is, 0, 1, 0. The third row, 0 plus 5 by 2, this becomes 0. 5 by 2 minus 1 times 5 by 2, which becomes 5 by 2 only. And minus 5 by 2 minus 0 would become minus 5 by 2 only. This is what we have, right? Okay, this element also became 0 actually. 5 by 2 minus 5 by 2 will become 0. Right, that's the step that we have applied. Okay, check the calculations once again. Yeah, 3 by 2 times R2, 3 by 2 times R2 would be 0, 3 by 2 and minus 5 by 2 will remain as it is, and that's all right. What about the RHS? In the RHS as well, the second row R2 remains as it is. This is minus 1 by 5, 1 by 5, 0. This remains as it is. The first row is transformed. R1 plus 3 by 2 R2. So 1 by 2, 3 by 2 times this is added in this, right? 3 by 2 times 1 by 5, what is that? Minus 3 by 10. This is 5 by 10 minus 3 by 10. 5 by 10 minus 3 by 10 is 2 by 10, which is 1 by 5. Okay. This plus 3 by 2 times this, 3 by 10. This plus 3 by 2 times this, which is 0 only. R3 minus 5 by 2 times this, okay, minus 3 by 2, add minus 5 by 2 into minus 1 by 5, which is plus 1 by 2, minus 3 by 2 plus 1 by 2, minus 3 by 2, minus 2 by 2, which is minus 1, okay. 0 minus 5 by 2 times 1 by 5, so minus 1 by 2, this is minus 1 by 2. 1 minus 5 by 2 times 0 is 1 only, right? This is what you get. Calculations have to be done very carefully. And what else? What else? Once you have dealt with this column, then now is the turn of this column, and we'll have to convert this element into a 1 first. So let's do it. R3 can be replaced by R3 times minus 2 by 5, okay, reciprocal of this. And on doing this, what you get is 1, 0, 3 by 2 remain as it is, 0, 1, 0 remains as it is, 0, 0, 1, this is what it becomes. What next? On the right hand side, the first two rows will remain as it is. This is 1 by 5, this is 3 by 10, this is 0, this is minus 1 by 5, this is 1 by 5, this is 0, and you'll have to multiply this with minus 2 by 5, okay. Minus 1 minus 2 by 5 will become 2 by 5, okay. And minus 2, minus minus will get cancelled, 2 and 2 gets cancelled, this is 1 by 5. 1 times minus 2 by 5 is minus 2 by 5, okay. This times A, this is what you get. On the RHS, this is what you get. What next? One more step remains. Convert this into a 0 using this. So R1, the next step that will apply is, next step, we'll continue over here. R1 is replaced with R1 minus 3 by 2 times R3. Okay, what does that give me? This gives me 1, 0, 0, 0, 1, 0, 0, 0, 1. This is pretty simple. And what else? On the right hand side, R1 gets replaced with something, R2 and R3 remain as it is. So let me write minus 1 by 5, 1 by 5, 0, this remains as it is. 2 by 5, 1 by 5, minus 2 by 5 remains as it is. This matrix A remains as it is. And what I am replacing, R1 is R1 minus 3 by 2 R3. So this minus 3 by 2 times this, okay, let's do that. 3 by 2 into 2 by 5 is 3 by 5. 1 by 5 minus 3 by 5 is minus 2 by 5. This minus 3 by 2 times this. Now 3 by 2 times 1 by 5 is 3 by 10. 3 by 10 minus 3 by 10 is actually 0, okay. Minus 3 by 10 gets multiplied with this. What do you get? 0 plus 3 into 2, 3 by 2. So 3 by 5. This is what you get. 0 plus 3 by 5 will become 3 by 5 over here. This is what I am getting. And this here is identity matrix. This should be the inverse, and this is matrix A. Therefore, A inverse is equal to this matrix. Minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5. This should be my answer, but please do one more thing. What is that? One more thing is required, that is verification of this result, right? And how do we verify this? We multiply with A and check whether this is the inverse or not. So check is remaining. Let's check. Excuse me. A times A inverse, what is that giving me? A is 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2 times another matrix. What is that? Minus 2 by 5, 0, 3 by 5, and minus 1 by 5, 1 by 5, 0. This here is 1 by 5. Okay, this is 2 by 5, this is 1 by 5, and this is minus 2 by 5. So checking is very important, and let's check this answer that we have just obtained. Okay, we'll have to multiply them together and see what do we get over here. 2 times minus 2 by 5 is minus 4 by 5, okay. Minus 3 times minus 1 by 5 would be 3 by 5. And 3 times 2 is 6 by 5. What you get is 6 plus 3, 9 minus 4 is 5 by 5, which is 1, okay, that's cool. 2 times 0 is gone, minus 3 by 5 plus 3 by 5 is 0, good. 6 by 5 minus 0 is gone, minus 6 by 5 is again 0. This is what I get, okay. First element is 1, second element, third element. In the first row are all 0. Next, minus 4 by 5, minus 2 by 5, plus 6 by 5. Minus 4 by 5, minus 2 by 5 is minus 6 by 5, plus 6 by 5 will be 0, okay, this converts to 0. 0 plus 2 by 5 plus 3 by 5. 2 by 5 plus 3 by 5 is 5 by 5, which is okay. 6 by 5 is 0, and minus 6 by 5 is a 0, as you may observe over here, right? What next? minus 6 by 5 plus 2 by 5 plus 4 by 5. Minus 6 plus 2 plus 4 is 0 by 5, which is 0. 3 times 0 is gone, minus 2 by 5 plus 2 by 5 is again 0. 3 times 3 is 9 by 5, 0 is gone, minus 4 by 5. 9 by 5 minus 4 by 5 is 5 by 5. Yes. And yes, this is 1, 0, 0, 0, 1, 0, 0, 0, 1, which is the identity matrix. This is okay, the check is okay, and yes, this is the correct answer for this question over here. That's the matrix, that's the inverse matrix, as you may observe over here. Is that all? Yes, this is all in this question.